So hi guys, how are you all? So welcome to the 50 most important session of your NEST 2026. So in this session we are going to discuss your 50 most important questions. So basically in this session what we are going to do again, just like IIT session, I won't waste a lot of time, but I will just tell you that thing that if I am discussing 50 questions here, it does not mean that I am predicting the exam of NEST 2026 by any means. I am predicting the concepts. I am not predicting the questions. Okay, so if you are doing 50 questions here, it does not mean that you will do these 50 questions and your exam will be cleared and all. No, your job is not finished by just seeing these 50 questions. You have to see the concepts, then you have to go back, then you have to revise all the concepts, and then you have to do more and more questions regarding those concepts. Because even though the questions that I am going to discuss, even if they don't come, okay, there is a great possibility that their concept might be asked in some other way, in some other question, okay, in some other form. Okay, questions might not be repeated, but concepts, there is a high probability that they will be repeated. Okay, so if we are going to discuss 50 concepts here, so at least in chemistry, like only 20 questions will be asked in chemistry in NEST. So among these 50 questions, at least 10 concepts, I think should be repeated. Not the questions but concepts. So again, and maybe more, if not 10, maybe more, 15, 12, 13, I don't know, but concepts will be repeated. Okay, so without wasting any further time, let's move forward with the questions. So we'll discuss the organic questions first. Okay, so this is the question. First question that we have is, in this question basically what they are saying is, see, so they are saying that this hydrogen, alpha hydrogen, this hydrogen and this hydrogen, these hydrogens are acidic hydrogen. Let me decrease the intensity of pen. Okay, these hydrogens, alpha hydrogens, attached to the electron withdrawing group. This is electron withdrawing group. Okay, these are acidic hydrogens that has been said in this question, and they have said that a carbon ion is formed when this acidic hydrogen are left, and this carbon ion is stabilized by resonance. Obviously, if this carbon ion is formed, so this will be stabilized by resonance, obviously. So this is resonance stabilized minus R effect, right? The point here is they have said that when it will attack on this CH3Cl, so what will be the product, and the base given is LDA. So they have given that LDA favors the ejection of least hindered acidic alpha proton. So least hindered acidic alpha proton is this. So what will happen? See, uh, okay, this is not benzene. Sorry. This is not benzene. Okay, so what will happen here? H, CH3, C double bond O. So LDA will come. Will come and take this hydrogen, acidic hydrogen, and it will be stabilized by plus R effect, minus R effect, sorry, O minus. So this will be the intermediate. After this will be formed, it will attack on CH3Cl, CH3Cl. So this will go to CH3Cl and Cl will be removed. So your final product will be this one. So you can see that C is your product here, right? So let's move on to second question. So you have to remember that LDA is a bulky base, so it will favor least hindered proton. Okay, so in this question, R is given, this reaction scheme is given, it reacts with KOH, then H3O plus, and the products are given. We have to find R and P. Okay, so if you see the final product, okay, this is dicarboxylic acid with the alkene in between of this. So basically when this R will react with KOH, what will happen? So if you see this D option, okay, so if this is my R, okay, if this KOH, OH minus takes this hydrogen, so what will happen? See, so this, wait, C double bond O, C double bond O, NH. So this is my R. If I take this as my R, okay. So what will happen? It will react with KOH. OH minus. So OH minus will take this H plus. So it will convert it into this anion and cation type situation, salt type situation, right? So after that, when it will attack on CH3Cl, see, okay. So if it will attack on CH3Cl, okay, if it will attack on CH3Cl, what will happen? So this is my P, okay. So this is my P. If it will attack on CH3Cl, so this will, nitrogen will attack on CH3Cl, right? So the product that will form is nitrogen CH3 double bond O, double bond O. Then what will happen? H3O plus is given, so acidic workup we are doing. So we are reacting this with water in acidic medium, obviously, right? So acidic medium plus water. This is acidic workup, right? H3O plus means that only. Okay. So what will happen? This nitrogen. I'm not saying that this is the only mechanism that is possible. There are other mechanisms that are possible. Okay. So whatever I think that will happen, I will tell that. I will explain that. Okay. If this will take H, this will attack on oxygen and this will leave. So OH2 positive, then NRH, okay, R is CH3 here, okay. Then this nitrogen will again take this hydrogen, okay. It will again take this hydrogen. If this will again take this hydrogen, again H2O will attack, this time on this carbon. So this will leave, right? So basically double bond O, OH, OH, double bond O. So while it will be leaving, so this will be leaving as NRH2. Okay, so this might take the extra proton. This will be OH2 positive, so this might take extra proton, and this proton will be leaving. So I'm not showing that. So that will be the mechanism. Kind of that will be the mechanism. Okay. So what will be left? Minus NRH2. So R is CH3. So this will be my product, right? And that is the product, right? And R is CH3, CH3 and H2 is left. So basically D is your option, right? This is R, this is P. Okay, sure. So basically this is the reaction given, reaction scheme is given, P is a reagent given. So from benzene, we have added this group to the benzene, this R group to the benzene, and we have asked that for the following conversion, what will be the highest possible yield? Like we need to tell which reagent should we use for highest possible yield. So there are two types of reagents here, which one is the correct answer, one is the answer which can one is the option which can confuse you. This one is the option which can confuse you. This is neopentyl chloride and anhydrous AlCl3. So what will happen? Benzene, when it will react with neopentyl chloride, so I will say chloride 1 2 3. This is neopentyl chloride. So with anhydrous AlCl3, what will happen? This Cl will form interaction with this, and this will be a very electropositive group or electrophilic group. So this benzene will react here. Either this can happen, or what can happen? If this benzene will react here, what will happen? The product that will be formed is this only, this one. Okay, the Cl will be removed. But there can be another thing. Generally what happens, you see here the rearrangement product. This is not rearranged. So the product that will be formed will be due to rearrangement. So this alkyl will attack here and chlorine will leave, and this carbon will have a positive charge now. Okay, so this will be the uh, reagent that benzene will attack at. Okay, so that should be erased. Yeah, this should be the reagent. So the product that should be formed from here is this. One, two, three, and this is the product. So maybe you will be confused that this product can be formed from this, but no, the required product won't be produced from this mechanism. This product will be formed. So basically this is the confusing option. This is not right. The right one is this. Okay, how? Because this is a very electrophilic group. See, anhydrous AlCl3, when it will interact with this chlorine, this is already electrophilic group because of double bond O. This will become more electrophilic, and when benzene will then attack on this, so this chlorine will be left, and after that, so when chlorine will be left, what will be formed? C double bond O. 1, 2, 3. Then after that we are doing Clemmensen reduction. Clemmensen reduction is basically the reagent that is uses zinc amalgam in the presence of acidic conditions. So basically what happens is it reduces the aldehydes and ketones to normal alkanes. So Clemmensen reduction. Clemmensen reduction. So the product formed will be what is required, this one. So the correct answer is this, C. Okay, so let's move on to next question. In this question again reaction mechanism is given, reaction scheme is given again. Okay, this is IIT PYQ. Okay, any other PYQ I have taken till now? No. Okay, so this is the first PYQ that I will be taking in organic chemistry. This is IIT 2017 PYQ. In this basically we have to protect one group. So this is a particular ketone, this is a particular ester. So we always know that ketones are more electrophilic. This is more electrophilic because here ester lone pair will be donated here, right? So this is not electrophilic enough. So these OH will attack on more electrophilic group and this will be protected. So your X will be OO PH double bond O OCH3. So this is your X. After that you will have to react this with LiAlH4. So LiAlH4 we all know that it is a reducing agent. So it reduces the ester into aldehyde, first aldehyde and then alcohol. So first it will do is what? It will remove this and hydrogen will be added. After that it will again react with it and it will convert aldehyde into primary alcohol. So obviously ester to aldehyde to primary alcohol. Okay, so this will be formed. So your product will be OOO PH. Okay, this will be alcohol, primary alcohol, right? So basically B. If along with H2O, H plus would have been given, you should have removed this as well. Deprotection will happen in acidic medium. Okay, so you can note down this point. If acidic medium is not given, you will not deprotect. But if acidic medium is given, if H plus is given, deprotect. Okay, so this is a good question, right? Chalo, let's move to next question, which is the fifth question. So in this question again we have to form the products first, and then we have to give the relationship between Q and S. So these are the major products of this reaction mechanism, right? We have to find the relationship between Q and S. So first do the reaction mechanism. So in this, what will happen? So this is aldehyde CH3 CH2 CH2. So aldehyde reacts with Grignard reagent CH3 CH2 COH. Grignard reagent, this is MEMGBr. So obviously it will reduce this aldehyde into secondary alcohol, 2-degree alcohol basically. CH3 CH2 C CH3 OH, right? So this is P, this is P. So after, you have to react this with H2SO4 and you have to heat. So this is dehydration reaction, right? Dehydration. So dehydration, in dehydration you will form alkene. Obviously H2O will be removed and alkene will be formed. So always make more stable alkene. More stable alkene that can be formed from this, from here can be formed alkene, from here we can form alkene, but we will form the most stable alkene. So your product will be, major product will be CH double bond C. This is H also, no? CH3. So this is my Q. The molecular formula here is C4H8 butene, right? So when we will do the same reaction with this, Grignard reagent will attack here and it will form 2-degree alcohol. So basically I am just writing R. So CH3, 2-degree alcohol, CH3, CH3. This is my R. Okay. So after that H2SO4. So you will again dehydrate H2SO4 and heat. So again, now you will have to make the most stable alkene, but here all the alkenes will be similar. So you make this alkene, this alkene, this alkene, whatever. So the alkene that will be formed is CH3, C, CH3, double bond CH2. So this is again C4H8, C4H8, and again that is butene. This is what 1 2 3, so 2 methyl prop 1ene. So again these both are what? Structural isomers. Structural isomers. Okay. So why I was taking the names, IUPAC name of these, because you have to revise IUPAC nomenclature as well. Don't leave it. Okay. We also have a question regarding IUPAC nomenclature at the end. I will show you. Okay. So it might be asked because IIT has asked and NEST will be asking. NEST also has asked. So basically from the previous years, like in recent years, they are moving towards these topics as well, like IUPAC nomenclature and all that stuff. Okay. So let's move to question number 6. Again, IIT PYQ 2021. Here, the first reaction that we are seeing is PDBSO4. So acyl chloride is reacting with it. This is acyl chloride reacting with PDBSO4. This is Rosenmund reaction. So I am writing the name reactions. You have to revise. So these are important reactions. This can come. So this will form. This will be aldehyde. CH3 COH. So this will be aldehyde P. So after that MEMGBr will attack here and H3O plus. So this will form into 2-degree alcohol. So this will be CH3. This is CH3 and 2-degree alcohol OH, right? So after that chromyl oxide CrO3. So always remember that this CrO3 generally it is present as CrO3 aqueous H2SO4 and acetone. Okay, so this reagent is Jones reagent. So this is a very strong reagent, strong oxidizing reagent. Okay, strong oxidizing agent. So what it does, it converts primary alcohol into acids and secondary alcohols into ketones. So primary alcohol, it converts into acid, and secondary alcohol into ketones. Okay, so what is this secondary alcohol? So your R will be a ketone. So this will be your ketone, right? So then obviously Clemmensen reduction, we just saw that Clemmensen reduction, Clemmensen reduction. So your S will be normal saturated hydrocarbon. So basically, which are the correct statement? So product S is a saturated hydrocarbon, that is correct. Second correct one is P and R can form addition products with NaCN H plus. So when NaCN and H plus, so basically NaCN is added in acidic conditions to your P and R. P is your aldehyde, R is your ketone. So aldehydes and ketones, always remember that aldehydes and ketones, aldehydes, ketones. Okay, so I will write just general formula RCO, R dash or H, whatever, aldehyde or ketone. When you are adding NaCN, when you are adding CN minus in acidic condition, so what happens is CN minus attacks here, so this opens up and it will take H plus. So that this forms cyanohydrin. Cyanohydrin is this RC CN RHOH. So this is your cyanohydrin. So this is basically a addition reaction. So basically what is happening, H is adding and CN is adding. So HCN is being added, but the reagent is not HCN, reagent is NaCN plus H plus. Okay, so this is addition reaction. Okay, so basically first and fourth are correct, so C is your correct option. Okay, sure. So again, next 2025 PYQ. So isopropyl benzene. So this is basically a question of Hawk's method of creating your phenol, okay, from benzene. So from benzene, first you will create cumene, then cumene hydroperoxide, then basically phenol and acetone. So basically just go and revise Hawk's method, okay, first of all. So that can be asked, if not directly, then in like these questions. So for example, when it is written isopropyl benzene is nothing but cumene. This is cumene only. What is it? This. So there is a hydrogen here. So when it reacts with oxygen, okay, in the air, what happens? It forms cumene hydroperoxide, OOH. So when then you will treat it with dilute HCl. So basically what will happen? It converts into phenol plus acetone. Okay, that happens. So this phenol is P, this phenol is P, and this is Q. So obviously there is a acidic hydrogen here in phenol. So this will give the hydrogen, it will turn to phenoxide ion, which will be stabilized by resonance. So this acidic hydrogen will turn blue litmus paper red, obviously, right? And P produces R upon reaction with chromic acid. So chromic acid is basically CrO3 plus H2SO4. That's only chromic acid, like Jones reagent, basically H2CrO4. H2CrO4? H2CrO4, H2CrO4, yeah. So chromic acid is that only. So basically if you react P with chromic acid, what will happen? CrO3 H2SO4. Okay, and acetone is also there. So this will convert into parabenzoquinone. Okay, okay, so your answer is A. Okay, so obviously I told you that this is a very strong oxidizing agent, so it will convert it into ketone, but it is because of this resonance and aromaticity, whole of the benzene converts to parabenzoquinone. You don't need to remember the mechanism of this, but okay, you can just see this. Okay, so let's move to the next question. In this question, basically the compound is given. Okay, in this question again Grignard reagent. So Grignard reagent is very important. So two equivalents of Grignard reagent is given. So first will attack here, second will attack here at cyanide. So at aldehyde it will convert it into 2-degree alcohol. Simple. But what will happen at cyanide? So at cyanide what happens? RC triple bond and C. RC array triple bond N. So when Grignard reagent attacks RMGBr, so it will attack at carbon, this will open up. So when this will open up, what will happen? RCR dash double bond N minus, right? So you put H3O plus H plus and H2O. So this will take H plus. So RCR dash NH. So again H plus is there, no? And H2O is there. So this will again take H plus. This will again attack here, right? So just like that, it keeps on happening at the end, what will be remaining? R dash. Okay, so basically it will convert it into ketone. So this N triple bond is replaced by R and double bond O, right? So basically this CH3 and ketone. Okay, and obviously CH3 and OH. So basically this is 2-degree alcohol, this is ketone. So A is your right answer. So let's move to, okay, this is NEST 2024 session 1 PYQ. In this question basically intramolecular aldol reaction is happening. So again read the terms properly. This is not intramolecular aldol condensation, this is reaction. Condensation is not there. H2O will not leave. Condensation means H2O will leave. Condensation is not there, reaction is there, right? So there are three methods by which this can happen. So first, this alpha hydrogen can attack here. Okay, this is my first one. Okay, second, this alpha hydrogen can attack at this carbon. This is my second one. Third, this alpha hydrogen can attack here, so this is my third one. So if we form the products of the first one, so 1 2 3 4 5, so 5 membered ring will be formed. 1 2 3 4 5. Okay, and okay, 1 1 2. Okay, so basically this will be OH. Wait, this will be OH. Okay, and then 3, then 4, then 5. Okay, so at 1 basically OCH3 will be there. Okay, so this will be my first product. Second product, green one. So 1 2 3 4 5 6 7. So make a 7 membered ring. 1 2 3 4 5 6 7. Okay, so this is my product. So then 1 wait 1 2 3 1 2 3 then 4. So there will be a OH, then 5, then 6, and then 1 2 3 at third carbon 1 2 3 there will be a double bond. Okay, so this will be the product of third one. Then second one, sorry, third one product, 1, 2, 3, 4, 5. 5-membered ring will be there. Make 5-membered ring. Right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here OH and CH3 will be there, and on the first carbon there will be CHO group. CHO group, right? So these are the 3 products that can be formed. So they have asked one of the products that can be formed is. So one of the products that can be formed is this one, D. If you see. So OH and COCH3, right? So this is the only product that can be formed. You can be confused with this also, but here if you see, OH is at second carbon. So second carbon is OH. So their OH is at this carbon. OH should be at this one. So this is not the product. And obviously all others are not matching, right? So only option is, I think, D here, right? Okay, sure. So this is the 10th question. So this question is also a good question. Basically, reaction scheme is given. We have to find the Y. So we have to find this product, right? So what will happen? See. So whenever oxygen and phosphorus are there, so always interact the lone pairs of oxygen with phosphorus, because phosphorus is your, this is PCl3, PCl5. Okay. Okay. So what will happen? See. So oxygen lone pair will donate here because phosphorus is a what? Electrophile, because 5 chlorine are there. So when this will happen, one of the chlorine will attack here and this bond will open up. So your intermediate that will form is OPCl4Cl. Okay, then again there is again a lone pair. It will again attack here and again one of the Cl will attack here and this oxygen bond will break. So what will happen? 2 Cl will come in place of double bond O and POCl3 will be removed. Okay, so this is my X. So when this X is treated with alcoholic KOH and obviously there is heat given. So OH minus and heat. If heat would not have been given, then substitution product would also have been to some extent, or I don't know with what extent it would have been, but majorly then it would have been substitution product. But because of this heat, you will write elimination product, because elimination is a thermodynamically controlled reaction, so it happens at high temperatures. So obviously this will attack at beta hydrogen and chlorine will be removed. So your answer will be, it will be C. Okay, so this will be PCl5. Okay, please don't worry. Okay, chalo. So again, next 2024 session 1 question. So basically in this question, among the following ethers, Williamson ether synthesis, which of the ethers can be synthesized under mild conditions using Williamson ether synthesis? So Williamson ether synthesis is what? So this is again a named reaction, right? So what happens? Any alcohol reacts with base. So this base takes this hydrogen, acidic hydrogen, it converts into RO minus. So this RO minus then reacts at R leaving group. So this is a good leaving group. This generally is a halogen. In Williamson ether synthesis, this is alkyl halides generally. So, but can happen with other leaving groups as well. Okay, so that's a concept that you should not miss. So here RO minus will substitute the leaving group which will be halogen, so your ether will be formed. So RO R dash. Okay, so basically for SN2, this R dash, first of all, what will happen? This R dash should be sp3 hybridized. Second, this R dash should be less bulky. Less bulky means it can be 1 degree, it's fine. It can be 2 degree is also fine, but 3 degree is a very bulky carbon atom. So at 3 degree carbon atom SN2 does not happen. Okay, and obviously it should be sp3 hybridized. So if you see, I'm just doing first one. You have to try each and every one like that only. Okay, so this is a ether. This can be formed by two things, either this O minus, this alkoxy ion reacts at what, Cl, for example, any good leaving group. Either this reacts at this, so this will leave. So but this is a 3 degree carbon, so this can't happen. Or that alkoxy ion O minus can attack at this chloride. So again, this is sp2 carbon, so this also can't happen. So basically this ether can't be formed through your Williamson ether synthesis. Similarly, this is sp2 carbon, this is sp2 carbon, can't be formed. Similarly, this is bulky carbon, but this is sp3 carbon. So what can happen? O minus will attack at Cl. So this can replace Cl by SN2 mechanism. So this ether can be formed. Similarly, this ether can also be formed. Same group is there, right? So basically 3 and 4 can be formed. So C is your answer, right? Chalo. So again, as 2024 session 1 P by Q. So this is SO3H group, so molten NaOH, and heat is given and sodium salt is formed. This sodium salt is obviously like phenoxide ion, right? So phenoxide ion with your Na plus. So this will be the structure of Q. Okay, so because OH will first replace this SO3H, so OH will then go into phenoxide ion and Na plus will be there. So that is the thing. So after that Q is formed. So Q, after reacting with what? CH3I will form your methoxybenzene, OCH3, but with CO2 and H plus. So this is kind of just like coal-based reaction. Coal-based you have to study. I am writing here. Just like it. This is not coal-based reaction. Like static material is not like coal-based reaction. Static material for coal-based reaction is your phenol. But then again, phenoxide is an intermediate of coal-based reaction. So this is a coal-based reaction only. Okay. So what happens is this phenoxide ion O minus, and there is a H plus as well. So basically what happens, this O minus uh, mm, okay, wait, this O minus interacts with Na plus, and what happens then, this goes back to the resonance on conjugation, and then C double bond O, it attacks at C double bond O, and this oxygen opens up. So your structure that will be formed is double bond O, CO O minus. But then what happens is there is a hydrogen. So this hydrogen will then again leave and will take this, and this will form your OH and COOH. So your 2-hydroxybenzoic acid, salicylic acid, right? So basically this will be formed. So methoxybenzene and 2-hydroxybenzoic acid, right? So that is the mechanism. Okay, so let's move to question number 13. We have to identify the major product 3. So this is the major product. Again, HNO3 and H2SO4. So these are nitration reagents. So you will do nitration here. Okay, so because bromine is electron donating group, so ortho and para will be more susceptible to the nitration, but point is ortho won't be preferred that much. It will be minor because bromine is a bulky group, so nitro will interact with bromine, there will be steric hindrance. So your first product will be bromine NO2, para bromo nitrobenzene or para nitrobromobenzene, whatever. Okay. So magnesium and dry ether. So magnesium will then form Grignard reagent. Grignard reagent is very important again and again. Questions are telling us, right? So this will be Mg, Br, and O2. This will be second. After that, CO2 dries just like we did right now, coal-based reagent, right? So this will attack at CO2, and then it will form your carboxylic acid. Simple. NO2COOH. So your para nitrobenzoic acid. Okay, that will be your product 3. Okay, so let's move to question number 14 here. So basically this is Finkelstein reaction. So Finkelstein reaction is basically SN2 mechanism. So basically this is halogen exchange reaction. So what is Finkelstein reaction? This is halogen exchange via SN2 pathway. Okay, so what happens is, so basically there is NAI product. NAI is the reagent here, and you take RX, you react it with NAI, so this R will then attack at Na, not Na, wait, this I will attack it. What am I doing? So this I minus will attack at the back of R with SN2, so this X will leave. So when this X will leave, so this is halogen exchange reaction, so this will be Ri plus NaX. This NaX will precipitate out, so that is your Finkelstein reaction. So in this, for SN2 again, there is a same thing, that there should be sp3 and less bulky, right? So basically again this is sp3. So here Finkelstein reaction can happen, I can attack, but here I can't attack. This is sp2 hybridized. Here again I can't attack again. So here I can attack. So 1 and 4 can go, but the question is asking which will not undergo. So always read the question properly. So which will not undergo? 2 and 3 will not undergo that. 1 and 4 will undergo, and 2 and 3. Wait. 2 and 3, A. 2 and 3 will not undergo. Okay. Chalo. Next question is 15th question. So again, GOC is also important. And as seldomly asked from GOC, but can ask, right? So which of the following is the correct decreasing order of basicity? So basically we need to, as I said, we need to decrease these compounds in decreasing order of basicity. Okay. So here if you see, the competition is between, so basicity is basically tendency to give electrons, donate, lone pair, right? So first of all, basically if you see, these have 3 lone pair donators, 3 nitrogen, 1 2 3, right? First thing is that. Then second and first have 2 lone pair donators, and this has 1 lone pair donator, and obviously this is not the only factor that we will see, but this is 1 lone pair donator, and this is sp2 hybridized. So sp2 hybridized, and then nitrogen is already electronegative, and apart from that it is sp2 hybridized, part of the aromatic system. So tendency of it to give this lone pair will be less. So obviously this will be least, fourth will be least. Okay, then we talk about third, second and first. Okay, now this can be a bit confusing. So here if you see third, if this lone pair attacks here, goes into conjugation, this will open up and go into minus charge. Similarly, if this attacks here, this will again go into minus charge. So at any particular time, if one lone pair is going into conjugation, other will be available for donation. So at one particular time, two lone pairs are not involved in conjugation at the same time. So if this is involved in conjugation, this will be available. Okay. Then if you see first and second, there is only one lone pair here. So if this will be involved in conjugation here, there will be a minus charge. Simple. So obviously that minus charge can be also donated. This can also be donated. I'm not saying this can't be donated. This can also be donated. This will also be donated. That is the thing. But only difference between second and third is there is one lone pair which will be available, because when this will be in conjugation, this will be available. So here, obviously there will be a lone pair. So this lone pair will be in conjugation to make this compound as aromatic. So if this will be in conjugation, here there will be a negative charge. So again, if this will be in conjugation, here there will be a negative charge. So basically, but point is the lone pair of these will be available. These lone pair will be available. So again, point is here what will be available to donate? This lone pair, nitrogen lone pair, and this negative charge of carbon, whatever, right? But the point is this negative charge will be in closed cycle, closed loop of conjugation. So this is kind of bit stable, so this is not easy to give, but this is readily available just like this. But again, then there is a point that basically, obviously this is more basic, third is the most basic here, right? So third most, fourth least, is there any option? Third most, fourth least. So two options are there, A and C. So among these again, there will be two lone pair donors here. See, there are two lone pair donors. This lone pair, if you see, is not donatable. This is involved in conjugation. Okay, so only one lone pair donation is happening here. Similar to that. Okay, so basically, I think the correct option will be 3, 2, 1, 4. Okay, is this fine? Tell me. Chalo, next. So in this, basically, this is the 16th question. So which of the following will form aromatic compound after loss of one hydride ion? So aromatic compound will be, aromatic compounds are, so always remember you have to see these aromaticity. Okay, don't be like NEST will not ask aromaticity, it can ask. So basically the molecule should be planar. Planar means all atoms with planar it should be all atoms are sp2 hybridized, and then 4n plus 2 pi electrons should be there. So n is basically, n can be 0, 1, 2, 3, so etc, etc, etc. So basically this is the rule for aromaticity. Any compound that will follow this rule, it will be aromatic. So if you remove this hydrogen, hydride ion, hydride, H minus will be removed, so this will have positive charge. So if you see this will be planar, and this has 4n plus 2, n is equals to 0 here, so 2 pi electrons, so this is aromatic. Okay, this again, if H minus will be left, this will be positive, so here 4 pi electrons are there, so 4n pi electrons are there. So if 4n pi electrons are there, it is anti-aromatic. Now all these conditions should also be followed, planar and sp2. It's not like any molecule containing 4n pi electrons is anti-aromatic, no. All these conditions are followed, but instead of 4n plus 2 pi electrons, 4n pi electrons are there, so it will be anti-aromatic. Okay, then H minus will be left, so plus, so this will be 1, 2, 3, and 6 pi electrons, so basically 4n plus 2 pi electrons, so again this will be aromatic again, and here plus, so this plus, there will be a bond formed here, so this will be just like your cyclobutene, right? So basically this is anti-aromatic, 4 pi electrons are there, so 1 and 3 are aromatic. Okay, chalo. Okay, so this is NEST 2021 session 1 from stereochemistry. So in this, 1 mole of D2 bromobutane D2-bromobutane, what is happening? 1, 2, 3, 4, 2-bromobutane is hydrolyzed in alkaline medium, OH minus is there. So this will replace this Br. Okay, so what is happening? To form butane to all and two forms of butane to all. So basically this is a optically active center, right? So if OH attacks from the side of Br only, so this will form some other enantiomer, and if it attacks from backside, this will form some other enantiomer. For example, this is one enantiomer, this is another enantiomer, right? So butane to all. So in this they have said that one butane to all and okay, L-butane to all. I don't know whatever it is. Let's suppose this is L isomer, this is D isomer. Let's suppose. So they have said that L isomer is rate of formation is assumed to be twice as that of D1. So basically, whatever this is, whatever this will be converted into this, the ratio will be 2:1. Okay. So mole fraction will be 2/3. Total moles 3, 2/3, 1/3, right? So if mole fraction is this, and they have said for the D isomer, so L is assumed to be twice, right? But for the D isomer, the specific rotation is plus 13.5. So for L isomer, the specific rotation will be minus 13.5 because isomers have equal and opposite rotations. Okay. So after complete reaction, specific rotation of the product. So specific rotation of the product mixture will be is mole fraction of one isomer into specific rotation of that isomer plus mole fraction of other isomer into specific rotation of that isomer. So 2/3 minus 13.5 plus 1/3 13.5. So this will be equal to your minus 4.5 degree. Obviously specific rotation will obviously be in minus because this is twice. The minus one, the L form, the rate of formation of L form is assumed to be twice that of D form. So D form specific rotation is plus, so L form is minus. So obviously L form, the minus one, is twice as that much of plus one. So obviously the specific rotation will be in minus. So that is also a hint. So your option will be minus 4.5 degree. Okay. So in this question, basically we have to identify the relationship between the following compounds. Okay, so if you see, if you invert this, like you pull this out of the board, and you make it like this. So this is right now hydrogen is out of the board, like this. Hydrogen is like this. So if I pull this, this hydrogen will go and will go into the board, and this OH will come out of the board. So this will be formed as what? This will be formed as, I'm just thinking about geometry right now. We'll do by RS configuration as well, don't worry. So this will be OH H, okay, and CH2 OH. So point is, this seems like a okay, so there will be a double bond there, not here, on this carbon, okay. So this seems like a enantiomer or what? So now if you, okay, so now if you rotate this again, so CH2OH will go there, CH2OH will go there, wait. So if you rotate this, then this double bond CH2OH and OH will go inside and H will go outside. So basically this is again not basically this is not a stereoisomer of this. This will be diastereomer. Let's check. Let's recheck this using RS configuration. So basically, if this is 1, this is 1. Let's suppose this is 2, 3. So this will be 4. So 1, 2, 3. So this is what clockwise. So R, but at the wedge position, fourth priority is there. So this will be S. Okay. Obviously 1, 2, 3 clockwise. So this will be anti-clockwise. Then here 1, 2, 3, and fourth priority is again on your uh, wedge position. So 1, 2, 3 anti-clockwise. 1, 2, 3 anti-clockwise. So this will be R. So this is coming out to be RNS. As per the RNS, this is coming out to be enantiomer. So whatever is coming out to be enantiomer, whatever is coming out to be as per the RNS configuration. We might have made some mistake by analyzing the geometry, but RNS configuration can never be wrong. We can again check this. See 1, 2, 3. So 1, 2, 3. So priorities are fine. So 1, 2, 3 is clockwise. So this will be anti-clockwise S, because fourth is at wedge position. Then 1, 2, 3. So this will be again anti-clockwise. So this will be clockwise. So this will be R. So as per RNS configurations, this is your enantiomer. So maybe we have made some mistake. You can analyze the geometry again, but it will be enantiomer. Okay, sure. So again, I would tell you that always when relationship is asked, it's okay if you have time, you can analyze the geometry, but sometimes geometry can be wrong. See, if I am doing geometry wrong, so it's a very high probability that you can also do the geometry wrong. You can also analyze the geometry wrong. Not everyone is very is a master of stereochemistry. Not everyone can imagine things like that. Like right now, I couldn't imagine. But the point is, if we can't, we can fail. So this RNS will never fail. So always analyze using RNS. Okay. So then 19th question. In this, basically, this is the compound given, and in this compound, your reaction mechanism is given. We have to find the structure of Q. So NaNH2, NH2 minus is a base. So NH2 minus will take hydrogen of your alkyne, because this hydrogen of alkyne is acidic one, because this carbon is sp hybridized. This is sp hybridized, so negative charge on this will be stable, kind of stable. So when this will attack at hydrogen, this sp hybridized will then attack at Et. So the product P will be, wait, oxygen, Et. Okay, so this is my product P. After that, they have given Na liquid NH3. This is your Birch reagent. So Birch reduction will happen. So basically, if alkyne is given, there can be two things for reduction of alkyne. Like they can give two things. First is Birch reduction, NaNH3. Second is your Lindlar's catalyst. Lindlar's catalyst. Okay, this Lindlar's catalyst is H2 and palladium salt. Palladium and calcium sulfate, calcium salt, basically Ca2 plus, lead 2 plus. So basically these are the Lindlar's catalyst. So if this is given, so and if Birch reduction is given, so you will convert this alkyne to transalkene. Okay, see, so the oxygen, okay, so 1, 2, 3, Et. See, transalkene, right? But here in Lindlar's catalyst, alkyne will be converted into cisalkene. So this same quotient could have been made like this by using Lindlar's catalyst. So your 1, 2, 3, Et. So this could have been the answer in Lindlar's catalyst. This is the answer in your Birch reduction. So C is your answer. Okay. Okay. So this concept you need to revise. Then, so again I told you we have a IUPAC nomenclature question. So please don't miss these topics like IUPAC and organic chemistry, GOC basically, and stereoisomerism something. Don't be like that we'll just do reaction mechanism, aldehyde, ketone and phenol and everything will be fine. No, no. Do everything. Okay. So what will be the correct IUPAC nomenclature of the given compound? So in this compound, first find the largest chain. Largest chain will be 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4. Any chain will be largest, but point is this chain that we have selected, this contains a alkene as well. Obviously, this is a primary functional group PFG. So we will consider this in the primary chain, that parent chain, obviously. So any chain 1, 2, 3, 4, 1, 2, 3, 4, any chain we take, it's fine. Both are 4 membered, but the point is this chain that we are taking, it contains a alkene, right? So this chain that we are taking will be the primary chain, but point is the numbering can be done from the opposite side as well. 1, 2, 3, 4. But then again, from the opposite side, the primary functional group is getting third priority, third number. So we have to give lowest number to the primary functional group. So primary functional group here is ketone. So we will give 2 number to it. So numbering will be this only. So your nomenclature will be 3 methyl. This is methyl. 3 methyl. Then 2, 1, 2, 3, 4. So this is butane, butanon, butane 2 on. So but this is butene. So but 1 in 2 on, right? A second, not 1. Why am I doing from 1? This is 3 now. We are taking this yellow numbering. I got confused. We are not taking blue numbering. We are taking yellow numbering. So this will be but 3 in 2 on. Okay. And ene will not contain a E because after ene there is O, right? So this will be 3 methyl but 3 enone, right? So this is your correct answer for the organic section. So we have finished the organic section. Now we'll move to physical section. Okay, chalo. Okay, so let's move on to now our physical and inorganic section of the next 50 most important questions, right? So okay, so this is question number 21st. So basically here we have to find the total number of significant figures in the result of this. So basically last year only Nest has asked the question regarding the significant figures, so we can't miss these things. Okay, so basically first of all you have to find for what? Addition and subtraction. So always remember that in addition and subtraction the result will always contain, wait a second, let me the result will always contain that many decimal places which will be equal to the number which contains the least number of decimal places. What I am trying to say is result contains decimal places equivalent to the number with least decimal places. So first do addition and subtraction and find the answer and then round it off to the decimal places that will be equivalent to the number with the least number of decimal places. So here both the numbers 29.4 and 21.4 have one decimal place. So basically there is nothing to worry. Both the numbers have one decimal place, so our answer of the subtraction will be expressed in one decimal place. So this 29.4 minus 21.4 will be 8.0, right? One decimal place. Now 8.0 into 1.86 into 10 to the power 3 divided by 1.78. So now in multiplication and division, always remember that the result of multiplication and division will have the significant figures equivalent to the number with least number of significant figures. So here result will have significant figures equivalent to the number with least significant figures. So if you don't know the rules how to calculate the significant figures in a number, so please revise that. So this question is a hint for that only. Okay, so basically this number contains two significant figures, this number contains three significant figures, and obviously this number contains three significant figures. So the number with the least significant figures is 2, like two significant figures. So your answer will have two significant figures. Okay, so please revise the rules for calculating the number of significant figures. There are 4 to 5 rules, not more than that. Okay, okay, next question is a crystalline hydrated salt is given and it has been said that it has been rendered anhydrous, loses 45.6% of its weight. So crystalline hydrated salt is AXBY dot XH2. So they are saying that when it became anhydrous, it lost 45.6% of its weight. So basically, if it becomes anhydrous, it loses water. So they are saying that water was 55.6% of its weight. Okay. Next, percentage composition is given. Percentage composition is given. So if you take the compound, let's take the compound to be 100 grams. Okay. So aluminium is 10.5%, so 10.5 gram. Potassium is 15.1%, so 15.1 gram. Sulfur is 24.8 gram, and oxygen is 49.6 gram. So basically, what you need to do, you need to calculate the number of moles. 10.5 divided by molar mass, which is 27. This will be 0.38 approximately. Then 15.1 divided by 39, this will be also equal to 0.38 approximately. Then 24.8 divided by 32, this will be almost equal to 0.77. And then the calculations can be wrong, you can check once, but more or less they will be same. 49.6 divided by 16, this was basically 3, around 3.1. Okay, this will be around 3.1. So you divide all of this by 0.38. Obviously you need to find the smallest whole number ratio for finding the empirical formula, right? So divide all of this by 0.38. So this will be 1. 0.38 divided by 0.381, 0.77 divided by 0.382, 3.1 divided by 0.38 will be 8. Okay, somewhere around 8. Okay, so your empirical formula for this compound will be AlKSi2O8. But the point is H2O is missing. H2O is missing. So whatever will be the mass of this whole empirical formula mass, let's suppose this is XH2O, right? The mass of this will be mass of this whole anhydrous form. So this will be around 258, I think. This will be around 258. I would say 8 into 16 is 8 6 84, 128. 128 plus your, then this is silicon or sulfur? This is sulfur, right? What did I do? Sulfur 2O8. Okay, so this is basically 8 into 16 is basically 128. 128 plus 64, 188, 192, 192 plus 39, 2, 42, 251, 251 plus 27, 278, I think, right? 251 plus 27, 278. So 278 plus XH2O. So X into 18. So this will be the empirical formula mass. So this X into H2O, X into H2O 18 divided by 278 plus X 18 divided by total empirical formula mass into 100 is given as 45.6%, right? So you will calculate this, x will come out to be 12. Okay, even if you don't, this question is a bit easier still, because the only option is this. For the correct empirical formula mass or empirical formula of the anhydrous part, the correct option is this. None of the other options contains the correct empirical formula. Okay, that is the point. But if in the exam, you know, the options are not so easy, then how to do this? Okay, this calculation can be around 278, 258, whatever. Check the correct mass and do the calculations. I don't exactly remember the things. Okay, chalo. So basically in this question, electronic transition is happening, and from R1 to R2 it is happening in initial state to final state. And if you see the options, all the initial states are higher than the final state. So it is going from higher state to lower state. Okay, the difference in the orbital radius is given R1 minus R2 is 24 times. So R1 minus R2 is equals to A naught N1 square by Z minus A naught N2 square by Z. Okay, this is the thing. And Z, if nothing is given, you will take Z as 1. Okay, if nothing is given, take Z as 1. So this whole R1 minus R2, so this will be A naught N1 square minus N2 square. So the difference in the orbital radius is 24 times the first Bohr radius. So this is 24 times A naught. First Bohr radius is A naught for hydrogen, right? So A naught will be cancelled out. So this will be N1 square minus N2 square is equals to 24. The square of two numbers will be 24. So this will be 5 minus 1. 5 square 25 minus 1 24. Okay. Chalo. So in this question, basically whatever is given, everything is written. So delta G is written, delta G of system, delta H system minus T delta S and all that stuff, and they have given the delta G. If it is greater than 0, then it is non-spontaneous. If it is less than 0, then the reaction is, or the process is spontaneous. If it is equal to 0, then the process is in equilibrium. We all know that. And they also have given the relationship between log K equilibrium and delta G. Now they have asked for reaction to be spontaneous at all temperatures. So what should be the case? So delta G is delta H minus T delta S. So it should be spontaneous at all cases. So that means in all temperatures. So that means delta G should be always less than 0. So for that, if this is delta G is less than 0, this is negative. So delta H should also be negative. Delta H should also be less than 0. And if delta H is less than 0, then you are subtracting T delta S. So if delta S is positive, is delta S is greater than 0. For example, you want to keep delta G as negative. So for example, delta H is, let's suppose this is minus 2. I am taking any number. So temperature is obviously, let's say 273 Kelvin, 0 degrees Celsius, whatever it is, 273 Kelvin. Temperature can't be negative. Temperature will always be positive in Kelvin scale. So if delta S is positive, let's suppose this is positive 1. So minus 2 minus 273 will be negative. You put any number here, my 1, 2, 3, 4, 0 point something, whatever, but it is positive, and you put any number here, it is negative. So negative minus negative will be negative. So delta G will always be negative. Okay. So that's what they are asking. So delta G negative, delta H negative, delta S positive. Okay. Chalo. So basically this is a question given. So all this is given about adiabatic processes and isothermal processes, isothermal reversible processes and adiabatic processes. What they have given is that for isothermal processes, PV is equals to K, right? And for adiabatic processes, PV gamma is equals to K. Now they have said that based on this data, the graph that shows correct pressure volume relationship for isothermal reversible adiabatic and adiabatic reversible processes. So basically dotted line is for adiabatic and a solid line is for isothermal. So I am telling you the answer, I will tell how it is the answer. This is the answer. How it is the answer? See, this graph, if you see any other graph, this graph is between log P and log V. Okay, do this. For isothermal reversible for isothermal reversible log or I would say PV is constant. So take log both sides. So log P plus log V is equals to log K, right? So log P is equals to log K minus log V. So this is y is equals to mx graph, na? Y is equals to C minus mx. So slope here -1, right? So for adiabatic reversible, adiabatic reversible. Okay, so this is PV gamma constant, and gamma is Cp by Cv, and Cp is always greater than Cv. So gamma is always positive. Gamma is always positive. Okay, it is a Poisson's ratio, Cp by Cv. Okay, so basically take log both sides. Log P plus gamma log V log K, right? So log P will be log K minus gamma log V, right? So y is equals to C minus mx. Y is equals to C minus mx. So m here is minus gamma. So slope of adiabatic curve is gamma times magnitude. Magnitude is gamma times more. Slope is both of the slopes are negative, but magnitude of adiabatic curve is basically what? Gamma times. So basically this is your expansion, because volume is increasing, log V is increasing, that means volume is increasing, and log P is decreasing, that means pressure is decreasing. So pressure is decreasing and volume is increasing. So this is expansion. Every graph is for expansion. This is to nothing. So basically this is expansion. So if your log V is increasing, see, if your log V is increasing, this value will be more. So log K minus log V will be less. So log P will be less. So that is why your slope is negative, but adiabatic slope will be more negative. Slope is gamma times more negative, right? So if slope is gamma times more negative, so this is isothermal, this is adiabatic, gamma times more negative. Okay, chalo. So okay, in this question basically they have said that they have taken 100 mole of ideal gas in closed container with fitted movable frictionless weightless operating piston operating such that the pressure of the gas remains constant. So pressure is constant. So basically if pressure is constant, we will apply Charles law where V is directly proportional to T, right? So Charles law says that Charles law V is directly proportional to T. So basically correct variation of log V versus log T will be, so if you apply ideal gas, so PV is equals to nRT. So P is constant, V is equals to nR by P T, right? So T is this. So basically what will happen? Log V log nR by P plus log T. That will be the equation. So P is your 8.21, N is your 100. So P is in ATM and V will be in liters. So R will be 0.0821. So this will be log 100 into 0.0821 by 8.21 log T. So this will cancel out. So 10 to the power 2, 10 to the power 4. So 10 to the power 2 will remain. So this whole will cancel out. So this will be log 1 is 0. So this is plus, not multiply. So log V is equals to log T here, right? And if this is the case, so this is Y is equals to mx. So m is your slope, which is 1. If slope is 1, which means tan theta is 1, which means theta is equals to 45 degrees. So your correct option will be here, right? So log V will increase with log T linearly and C intercept is 0. and theta will be 45 degrees, slope is 1, right? Sure. So okay, then there is this equation given, which is your want of equation, right? Log k2 by log k1, log k2 by k1 delta h by 2.303 r. Want of equation, not want of equation, I think that is the name, right? So basically this equation, whatever is the name, I don't know, whatever is the name, this equation tells the variation of equilibrium constant with temperature. Okay, so k1 and k2 are temperatures at two are equilibrium constant at two temperatures T1 and T2, and we have to select the correct option. Okay, so the correct option here is value of K equilibrium always increases with increasing temperature. No, K equilibrium's value depends on the exothermic or endothermic part of the reaction. So this is wrong. For exothermic reaction, K equilibrium increases with decrease in temperature. See, always remember if K equilibrium if the reaction is exothermic or endothermic. So if it is exothermic, K equilibrium is inversely proportional to temperature. If it is endothermic, K equilibrium is directly proportional to temperature. So they have written for exothermic reaction, K equilibrium increases with decrease in temperature. So it is inversely proportional to temperature. So this will be right. So we will see also for endothermic reaction, K equilibrium increases. So they have said that for endothermic it is inversely proportional. No, for endothermic it is directly proportional. For exothermic reaction, slope is log kV. You can draw this slope and all. This will be wrong only. The correct option is this. If you want to do, you can draw the graph. Okay, it's fine. Chalo. So basically, this is the electrolysis Faraday's laws, electrochemistry, right? So in this they have asked the passage of current. Everything is given. Everything is written. Electrolysis is given. So basically they have given what? Electrolysis. Okay. Electrolysis. So in electrolysis what happens is you apply an external voltage, external battery, and you proceed with the non-spontaneous reaction. So that is electrolysis. That they have said the passage of current liberates H2 at cathode and Cl2 at anode. See, always remember if you are doing the electrolysis of NaCl in aqueous solution or NaCl in molten form. Okay, so in molten form there are no H plus or OH minus ion, there is no water, there is molten salt. So what happens is Na plus will be reduced to Na at your cathode and Cl minus will be oxidized to half Cl2 gas at anode. So that will be the reaction. Okay, in the aqueous solution there will be H plus and OH minus as well. So what will happen? H plus will be reduced to H2, half H2 at cathode, and obviously Cl minus will convert to half Cl2 at anode. Okay, so this is electrolysis part. If you don't know these things, if your concepts are weak about electrolysis, please go to our Hindi channel. You can go to a Hindi channel, you can see the rescue series that we have taken. I have specifically taken electrochemistry and chemical kinetics class, so there I have explained it in details. If you understand Hindi, you can go and watch that if this is not clear to you. But the point is, electrolysis of NaCl in aqueous and molten state will provide these products. So this will be NaCl. Answer will be NaCl. Okay, sure. NaCl in water. Okay. Okay, so again electrochemistry question. So E cell value is given. See, E cell, so Nernst equation, according to Nernst equation, E cell is E naught cell minus 0.059 by N log Q. Okay, at 298 Kelvin. Okay, temperature should be 298 Kelvin for this equation. Otherwise, it would be minus 2.303 RT by NF log Q. So Q is your reaction quotient. So Q is given here. See, Zn2 plus divided by Ag plus K square. Okay, so this will be E cell E naught cell minus 0.059 by 2. Okay, because 2 electrons are involved in the reaction. Log Zn 2 plus by Ag plus square. Okay, so they have asked which graph correctly represents E cell as a function of concentration of the cell. So they have asked, see here concentrations are going in -1 and +1. So these are not concentrations. Concentrations can't go in -1 and +1. They are talking about what? They are talking about what? This thing, log of concentration, log of Q. So if your Ag2 plus, if your Ag plus square is greater than Zn2 plus, so what will happen? This whole ratio of Zn2 plus divided by Ag plus square will be less than 1. If this will be less than 1, Q will be less than 1. If Q is less than 1, log will be negative. Log Q less than 0, right? If log Q is less than 0, E cell will be positive. See, so minus minus will get plus. So this means E cell will go on to be more and more positive as Q will go on to be less and less than 1. So if Q is going to be less and less than 1, E cell is going to be more and more positive. See, okay, okay, this thing. Second, if your Ag plus square is less than Zn2 plus, so this whole ratio will be greater than 1, obviously. So this means Q will be greater than 1. If Q is greater than 1, log Q will be negative, will be positive, sorry, what am I saying? If this is positive, this whole term will be negative. So E cell will go on decreasing. E cell will go on decreasing. So E cell will go on decreasing, and this is your C intercept. So this is 1.56 given in the question. So as your Q goes on increasing, log Q goes on increasing, more than 1, more than 0, so more positive, this means E cell decreases. Okay, okay, you can see. So your answer will be B. Okay, sure. So okay, this is chemical kinetics question. So basically radioactive isotope is given, half-life is given, okay, years to decay to Y. Okay, so X is decaying to Y. See here, in this question, X is decaying to Y. So at initial time, let's suppose this was N naught, this was 0. So at time T, this was N naught minus X, this was X. Okay, radioactive decay, general radioactive decay. So a sample of rock from moon was found to contain both the elements. So rock contained both X and Y in molar ratio. So this ratio N naught minus X by X was given to be 1:7. Okay, what is the age of the rock, right? From here, what we can do is, I won't do the whole calculation, I will tell you. So see, half-life is given. So T half of first order. See, all the radioactive isotopes follow first order kinetics. You should know that. First order. Okay, so if this is first order, T half will be 0.693 ln2 divided by K. Okay, K is rate constant. So from here you can find your rate constant. So K will be 0.693. So T half is in years, so K will be in years inverse. So T half is 6.93 into 10 to the power 9 years. Okay, so this will cancel out. So this will be 10 to the power minus 10 years inverse. So K is calculated, you calculated the rate constant. Now they are asking what is the age of the rock. So if you apply the first order integrated equation, so this will be log, or I would say, okay, so you can say log AT by A naught is equals to minus KT by 2.303. Okay, so AT is NT, NT is, so basically NT is N naught minus X and N naught is X. So this will be minus KT by 2.303, right? So N naught minus X by X. No, A naught was N naught, sorry. A naught was N naught. A naught was N naught. So from here you can find the value of X. You can find the value of X, na? See, N naught minus X into 7 is equals to X. So 7 N naught minus 7X is equals to X. So 7 N naught is equals to 8X. Okay, so from here you can find the value of X, or you can find the value of N naught, whatever you want to find. If you are finding the value of X, let's suppose, so X is 7 by 8 N naught. Okay, so put there. So log N naught minus 7 by 8 N naught by N naught minus KT 2.303. So this will be 8 minus 7 by 8. So this will be 1 by 8 N naught. So N naught and N naught will cancel. So log 8. Log 1 by 8 will be minus KT by 2.303. So log 8 will be 2.303 by KT. K value you know. Okay, 2.303 is there. Log 8 you can calculate, and from there time time, or that is the age. This time is the age only. This is the age. Okay, that is what has been asked. What is the age of the rock? So this will be equivalent to, the answer will be A. Okay, you can do the calculation. Answer will be A. Okay, chalo. So again a kinetics question. In this question, A to B is the reaction and rate constant is given. K1 is equals to matlab Arrhenius equation is given. K1 A1 e to the power minus e A1 by RT, and for XY reaction this is K2 A2 e to the power minus EA2 by RT. Okay, A1 is given, A2 is given, EA1 is given, and EA2 is given. So if you will do this, you will have to find the temperature at which K1 is equals to K2. So put K1 is equals to K2. So if you are putting K1 is equals to K2, so this will be A2 or A1 e to the power minus EA1 by RT is equals to A2 e to the power minus EA2 by RT. Okay, so A1 is given 10 to the power 9, or you can do this, A1 by A2 is equals to e to the power minus EA2 by RT divided by e to the power minus EA1 by RT, right? That is the thing. So this will be e to the power minus EA2 by RT plus EA1 by RT, because this will go up and it will be subtracted. So this will be e to the power minus EA1 minus EA2 by RT. Okay, so EA1 minus EA2, 1200 minus 1800. This will be minus 600. So minus and minus will cancel out. So this will be e to the power 600 by RT. R is given 2, and temperature we have to find. So this will be 300. Okay, so this is e to the power 300 T, 300 by T, and A1 is 10 to the power 9. So from here A1 is 10 to the power 9 divided by 10 to the power 10. So this will be 1 by 10 is equals to e to the power 200 by, okay, R is also there, no? R is also there. Wait, R is 2T. Okay, so this is done. Okay, wait, e to the power 200 300 by T. Okay, So basically what will be the answer then? They have asked the temperature. So we can take ln both sides, right? So this is A1 by A2, right? A1 by A2. A1 is given 10 to the power 9, 10 to the power minus 1. Okay. So ln 1 by 10 is equals to ln 300 by T. So there is something wrong here. There is something wrong here. There is something wrong here. Some calculation is mistaken. EA1 by RT. This is minus EA1 by RT. K2 is A2 e to the power minus EA2 by RT. Because this ln will be negative. This should not be negative. Wait. A2 e to the power minus EA2 by RT. So K1 is equals to K2. Okay. So then A1 by A2 e to the power minus EA2 by RT divided by minus EA1 by RT. So e to the power minus EA2 by RT minus EA1 by RT, right? So this will be EA1 by RT minus EA2 by RT. So you take 1 by RT common. EA1, this is the thing. See, so 1 by RT common. So this is plus, na? So EA1 by RT. So this is plus only. First of all, okay. So this is plus only. So this is minus 600, minus 300. Okay, okay. This is minus 300. So this is ln 1 by 10 minus 300 by T, or you can call it as ln 10 300 by T. Okay, so T will be 300 by ln 10. Ln 10 is 2.303. Okay, so C is your answer. So always make sure that your calculations are right. Such things can happen in the exam as well. So in this question, basically all of the large paragraph is given. So basically I'm not going to read the large paragraph. Basically they want you to find the correct block, period and group for atomic number 88. So you should know, for such kind of questions you should know the atomic numbers of the ideal gases, noble gases: helium, neon, argon, krypton, xenon, radon, organozone. So it's fine, organozone. Okay, radon is Rn, organozone is Og. So helium starts from 2, 10, 18, 36, 54, 50. Wait, not wait. Okay, ठीक है. 54, 36, then 32, 86, then 32, 118. So basically helium is your first period, neon is your second period, argon is third period, krypton is fourth period, xenon is fifth period, radon is sixth period, organozone is seventh period. So periodic table ends there for now. Okay, so obviously 88 atomic number will come after 86 atomic number. So after atomic number 86, 88 will come. So 88 atomic number will be in 88 atomic number will be in 7th period. And obviously its electronic configuration will be electronic configuration of radon. First of all, you will write all of the electronic configuration of radon, then you will add 2 electrons. So 2 electrons will go into 7s2. So this is 7th period S block and your second group. So 7th period S block, second group. Okay. So choose the correct order of the property given below. So again, this year basically S block and P block has also been added in the NEST syllabus, right? So basically this question can be termed as a P block question, and obviously general periodic question can also be this can also be termed as general periodic question, but this can also be termed as your P block question. So basically, if you see, the one concept that you need to remember here is, if you see the first option, you can be confused maybe, but there is nothing to be confused here. Ionic radius of C for any isoelectronic species, isoelectronic species with same number of electrons. Okay, so N3 minus has 10 electrons. Okay, similarly O2 minus has 10 electrons. So for any ionic species, any isoelectronic species, the atomic radius is directly proportional to negative charge and inversely proportional to positive charge. Higher the positive charge, lower will be the radius. Higher the negative charge, higher will be the radius. So higher negative charge, higher radius. Okay, so this is wrong. Now first ionization enthalpy of nitrogen is more than oxygen, even though oxygen is more electronegative. Why it is it? Because nitrogen's electronic configuration is 1s2, 2s2, 2p3. So it has half filled stable electronic configuration. Because of this, it does not want to take any extra electron, or it does not want to give its electrons, whatever it is. So basically, if you want to remove its electrons, its outermost electron, you will need to give more energy as compared to oxygen, even though effective nuclear force on oxygen is more, even though electronegativity of oxygen is more. This is the right answer. Second ionization energy of nitrogen will not be greater than oxygen. No. Second ionization energy won't be greater, only first. After it gives one electron, then it becomes 2p2 with a minus charge. Then it does not have any stable configuration or something like that. Okay, so there is no reason for it to have more ionization energy than O minus. Okay, then electron affinity, again I told you that electronegativity is minus electron affinity. Okay, so whatever is the electronegativity of oxygen, it is more. So it's basically they are asking about magnitude only. Okay, they're asking about magnitude. If you will take like that minus of electron affinity or something like that, I don't think that, maybe I said something wrong. Electronegativity is not exactly minus of activation electron affinity, or maybe it is. I have to check. I don't know. So I am not commenting anything on that. But the point is, here when they are asking about it, they are asking about the magnitude. Electronegativity, electron affinity, magnitudes are same. Okay, so obviously nitrogen's electronegativity is less, so oxygen's electronegativity is more, so electron affinity for oxygen will be more. So this is also incorrect. So the only correct order is first, B1. Okay, if I am not sure about the signs, electronegativity is equal to minus of electron affinity or not. If that is the case, please check at your end. If that is the case, then this will also be correct. If they are asking about the signs as well. Okay, so please revise all this: electron affinity, electronegativity, first ionization energy, electron gain enthalpy, and all that stuff. Okay, now, okay, so let's move to molecular orbital theory of chemical bonding. So they have said that if Z is the molecular axis, okay, so let's draw Z. Z is the molecular axis. This is Z. Okay. Then which of the following overlapping results in non-bonding molecular orbital? Non-bonding molecular orbital means they won't overlap. Non-bonding means the orbitals which basically don't overlap, which basically they don't make a bond together, right? So they are saying the following overlapping results in non-bonding molecular orbital, which means these orbitals are not overlapping, they are not bonding, so no overlap. Okay, so let's draw all the axes. this is your Y, and this is your X. Okay, Y, X. Okay, so if you see this D, XZ and D and PZ. So PZ will be, for example, there are two atoms. See, one atom is this, one one atom is this. Okay, so here let's suppose this has PZ orbital. This is PZ. PZ will be along the axis, along the internuclear axis. Internuclear axis is your Z axis. So this is PZ. So one will be in phase, one will be out of phase. That is the thing. Now second orbital here is DXZ. So DXZ will be somewhere between the axis of this, like this. Are you able to understand? So if you are able to understand properly, x-axis is here going inside, z-axis is here, so dxz will be here. Like if this is x-axis, this is z-axis, this is x-axis, my phone, and this is z-axis. Okay, this is z-axis, so it will be like between axis, so basically here. Okay, and pz is just along the z-axis. So pz is pointing towards the nucleus or towards the atom, and your dxz will be somewhere like that. Okay, somewhere like that. So basically this seems like they are trying to overlap, but if you are able to understand, this is this plane, this plane, this plane. Okay, so they are going inwards, and this face, this lobe is facing towards the atom, so they will not overlap. Okay, so this is your non-bonding molecular orbital. Now again, molecular orbital theory. So they have asked about B2 molecule. So B2 molecule electronic configuration you can write first. So B2 has 10 electrons. So obviously we will write according to the sp overlap, and sp mixing. Okay, so according to sp mixing, sigma 1s, sigma 1s star, sigma 2s, sigma 2s star. So because of sp mixing, sigma 2pz goes above then pi 2px and pi 2py. So it has pi 2px and pi 2py have lower energy than sigma 2pz. So fill 10 electrons, 2, 4, 6, 8, 9, 10. Done. So this is paramagnetic. So basically what we have to find, the B2 molecule will be diamagnetic when. So when it will be diamagnetic? So first is sp mixing is not operative. That is right answer, because if this is not operative, sp mixing is not operative, instead of pi 2px and pi 2py, there would have been sigma 2pz. So it would have contained 2 electrons altogether. So this would have been diamagnetic. Second one is sp mixing is operative, but Hund's rule is violated. So even if sp mixing is operative, so pi 2px and pi 2py would have been there. But Hund's rule says that if two or more degenerate orbitals are there, they will be first half filled and then they will be fully filled. Something like that, right? So if Hund's rule is violated, it means both the degenerate orbitals will not be first half filled. Any one of them can be fully filled first. So either this is fully filled or this is fully filled, whatever. You have to fill 2 electrons. No? So either this contains 2 electrons or this contains 2 electrons. In any case, this will be diamagnetic. Right? So basically, and the last one is sp mixing is operative and Hund's rule is not violated. So that will be this case, first case only. Okay. So 1 and 2 will cause your B2 molecule to be diamagnetic. Okay, so this is the question from coordination isomerism here. Which of the following complexes is or are optically inactive due to presence of plane of symmetry? This is MSQ. Obviously MSQ questions don't come in your nest anymore, but I have just given one just for the sake of it. So this is MSQ. Okay. So what happens is we have to find the plane of symmetry. So basically stereo, we have to see the plane of symmetry, which plane of symmetry will be there and which is optically inactive, right? We have to find optically inactive. So this is A, B, B, C. So okay, and okay, obviously these types of compounds will not contain plane of symmetry. So you can check for yourself. Obviously. So octahedral, your octahedral and bidentate ligands. So generally they don't contain plane of symmetry. So they won't contain plane of symmetry. This molecule will contain plane of symmetry. See, this molecule will contain plane of symmetry. This one. See, so a plane that will be, so this is square planar. So this is just like, this is my phone's plane. So this whole molecule is inside this plane. Like this is planar, square planar. Okay, square planar molecule, square planar. So if you put a plane which will be bisecting this plane, which will be bisecting this molecule in between the platinum, so these things will be mirror images of these things. Okay, so basically this is optically inactive. There is a POS. Okay, okay, and there is a COS as well. If you can see, there is a COS as well, right? And if you see A part, so this is not optically inactive. Let's just analyze this. So this is M, A, 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 B, B, C. Okay. So is there any plane going? Let's see. So plane like this, vertical plane. So no, B and C won't reflect each other if a vertical plane will pass. So plane like this, diagonal plane. So A and C won't pass. So this plane A and B won't. Obviously the answer will be then D only. Or maybe I think that there is, because C is one only, na, here. Here C is only one, if you can see. So maybe there is a printing mistake here. Let me check this question. Maybe there is a printing mistake in this question. Let me check this question. Wait. Okay, so basically I have checked the question. So basically this has been a bit misprinted. So here C was there. C was trans to each other. So if C is trans to each other, there will be a plane. I'm just telling you, I am not changing the quotient. Quotient is fine. Quotient is that is also a correct structure. I'm not saying that is not the correct structure. If such quotient comes, then this is only the optically inactive one. But if there is C, let's suppose there is C, so then there will be a plane which will pass like that, okay, like that, like diagonally. So it will contain this. This A and B. It will contain this A and B, right? Something like that. So this plane will cut diagonally, and C and C will reflect each other. So that will be optically active. So then A and D would have been the answer. Optically inactive, sorry. Then A and D would have been the answer, but in this case, your D would be the answer. Okay, chalo. So okay. So basically we have to consider square planar complex PtCl4 2 minus, and incoming ligand is ammonia. So what is happening? This ammonia is substituting chloride ligand in associative pathway. So associative pathway is just like your SN2 mechanism. For example, this is your R. For example, this is your C. Or not just like SN2 mechanism. You can also maybe assume addition and elimination reaction. Okay, addition elimination pathway. So what happens is in RCOX, right? So this is right now carbon is your sp2 hybridized. So when a nucleophile attacks here, okay, it opens up and an intermediate is being formed, RCX nucleophile O minus. So now the hybridization is sp3. Basically, the hybridization increases by 1, right? And then what happens is elimination happens. This X leaves, RC double bond OX. So something like that. N U. So I'm not saying the mechanism is like this. I'm saying something like that. Wait. I'm saying something like that is happening here. How? See, PtCl4, PtCl4, Cl4, Cl4. So what will happen when ammonia will come? It will first associate. It will first attack at platinum. It will first associate Cl, 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 ammonia. So from square planar geometry, it has gone to what? Square pyramidal geometry. Pyramidal. And after that, your Cl minus leaves. Okay, Cl minus leaves out. So then this will form your again Pt, NH3, Cl, Cl, Cl. So this will again form square planar. With so here coordination number is 4. Here coordination number is obviously 5. Coordination number means number of atoms connected to the central metal atom. So here coordination number is 5. Here coordination number is 4. So your correct answer will be coordination number 4, square planar. Starting complex is P. Transition state or intermediate is your square pyramidal with coordination number 5. Then your square planar with coordination number 4. Final product R. Okay. So in this question we have to find the correct melting point trend in the 3D series in your 3D and your 4D. So this is your 3D, this is 3D, this is 4D. So in this what happens is as you go along the group, so for example from scandium, so if you can see from scandium, vanadium to titanium, okay, what happens is your d electrons, your unpaired d electrons increase, unpaired d electrons increase. Okay, so metallic strength increases, right? Strength increases, metallic bond strength increases. So this means melting point also increases. Okay, then from chromium till manganese, melting point decreases. Chromium and manganese, melting point decreases. Why it decreases? Because in chromium and in manganese, in chromium if you see the electronic configuration is D4S2. So basically this is D5S1. So basically this electronic configuration is a bit stable. Also this one D5S2. So basically half filled electronic configurations are there, right? So because of these half filled electronic configuration, these electrons are not very much involved in metallic bond formation. So metallic bond strength, metallic bond strength decreases. Now here D5 is there but S is completely filled. So this configuration is more stable than chromium configuration. So obviously its metallic bond strength will increase more. So this will have lowest melting point. So here you will see this is manganese. Okay. And then again from iron to cobalt you can see. So or you can see till nickel, iron to nickel. So what happens is then electrons, then the stable configuration is not there, right? So then again the electrons increase. So again metallic bond increase, metallic strength increase, bond strength increase. So again melting point increase. But then again from copper to zinc, what happens is copper is again D10, D10 S1, zinc is D10 S2. So very stable configuration. So metallic bond strength decreases very much and melting point is very low. So lowest melting point in 3D series is of zinc. Zinc has the lowest melting point, zinc. Okay. So similar to this is the trend of the 4D series. 4D series just have higher melting point than 3D series because down the group melting point increases. Okay. So this will be your technetium, technetium, not technetium, technetium, and second is your manganese. Okay. Okay, so this is a good question. Basically, this is a question of photoelectric effect. In this question, they have given the photoelectric equation where they have said that kinetic energy is equals to absorbed energy minus work function. So this is the work function. This is the minimum energy required for electron to eject, right? So here nu naught and lambda naught are threshold frequency and wavelength. So they have asked the slope of straight line graph between stopping potential and frequency of incident light. So stopping potential is what? Stopping potential V naught is nothing but kinetic energy. Okay, so kinetic energy is this half mv square, right? So this will be h nu absorbed minus h nu naught, right? So h nu absorbed will be your, and we have to find between the frequency. So stopping potential and frequency. So we have to find the relationship. So you take h common. So nu absorbed minus nu naught. Okay. And stopping potential is also equal to EV. E charge of electron. Basically this kinetic energy is equal to EV naught. Okay. This kinetic energy is equal to EV naught. E charge of electron and V naught. Kinetic energy is there. Na? So any electron moving between the two electrodes of V naught potential have the energy equal to EV naught. So this kinetic energy will be equal to EV naught. Okay. Okay. So from here we can find the relation EV naught is equals to h nu absorbed minus h nu naught. Okay. So we have to plot a graph between stopping potential V naught and nu frequency of incident light, which is nu absorbed. So this will be V naught is equals to minus h by E nu naught plus h by E nu. Nu is the nu absorbed with so we have to make graph between these two. So this is y, this is my C, this is my M, this is X. So we have to find slope. Slope is Planck's constant by charge of electron. C. Okay. Okay. So basically this question is asking to minimize the painful effects of deep sea diving, oxygen diluted with less soluble helium gas is used by for breathing by divers. So why this happens? Because there is a law named as Henry's law. It explains this, right? So Henry's law says that solubility of any gas inside a particular solvent is directly proportional to the pressure of that gas above the solvent, right? So in deep sea water, as you go deep and deep, as you go deeper and deeper and deeper, basically your pressure wait, what am I, हाँ ठीक है, your pressure of gases increases. Pressure of gas nahi, pressure on the water. As you go deep down, the pressure on the water it increases, right? So basically what happens is your oxygen, the oxygen that is present in the water, it will just basically what will happen, it will just dissolve a lot faster. Okay, so they are using less soluble helium gas, so its solubility is less. So at the same pressure, when the pressure is high, if oxygen will dissolve more, helium will dissolve less. And obviously we don't need that much amount of oxygen. It can have very negative effect on us. So that is why we use oxygen diluted with less soluble helium gas. Why? Because at higher pressure, deep down the sea, at higher pressure, this helium won't just abruptly get absorbed in our bloodstreams like that. Like oxygen will, but helium won't. So obviously we will decrease the amount of oxygen and we will add some helium so that the pressure inside our blood veins does not increase abruptly and we don't get on any emergency like situation or something like that. So Henry's law is the example of this application. Okay. So this question is NEST 2020 session 1. So this is first PYQ in the physical section that I have taken from the NEST. So here equivalent conductance, the equation of equivalent conductance is given. Okay. So in this KCl and NaCl salts are given and we have to find the plot of kappa conductivity. So the plot of kappa is the conductance by 1 ml solution. Again, I have already explained this in the rescue series. So basically, yeah, it is not on this channel, but yeah, fine, it's okay. So if you want to see, you can go and see, check out. Okay, so the point is, this is kappa, conductance of 1 ml of solution. So this is concentration. So as the concentration of the solution increases, your ions of whatever ions are there, potassium plus, chloride plus, Na plus, Cl minus, whatever, which are providing the conductance to a solution, these ions increase per ml. So because these ions increase per ml, the conductivity will increase. So what will happen? The graph will be something like this. See, the graph will be something like this, but then it will reach a maximum value because too much ions will do the crowding of ions, right? So if in 1 ml there are too many ions, they won't be able to move properly. Ionic mobility will hamper, right? So there will be a maximum limit and then conductivity will decrease with concentration. Okay, so the point is, this graph is correct. Why? If you see two things, first, wait, if you see through two things, okay, so the maxima of this graph is at some concentration and maxima of this graph is at this concentration. Okay, so for KCl, the maximum limit of conductance or conductivity is at higher concentration as per this graph. Okay, this is CKCl, this is CNaCl. Let me write this, CNaCl. This is CNaCl. So point is why is it so? Because in water, in aqueous solution, the size of K plus is less than Na plus. Why? Na plus in originality is has less size than K plus, but in aqueous solution Na plus will have more hydration. So if it will be more hydrated, more water molecules will surround Na plus, so it will be a bulkier hydrated ion as compared to potassium plus. So if this will be bulkier ion, so as you increase the concentration of Na plus, the conductivity will increase. But because this is a bulkier ion, so per ml, let's suppose if this is a bulky ion, per ml it can have 10 ions, and then steric crowding will happen, then ionic mobility will hamper. But because this is a bulkier ion, that is happening. But if I'm talking about K plus, it is not as bulky as this, so it can maybe accommodate 12 ions per ml. till its limit is reached. So its limit will be reached at higher value of conductivity, obviously, because the ion is less bulky. So basically more ions can be accommodated in 1 ml. So basically more conductivity will be there till the limit will be reached, then conductivity will decrease down. So obviously KCl conductivity limit is at higher concentration, and obviously that limit is also higher, more conductivity, right? And obviously, yeah, fine. So that is the answer. So this was the next question. This was a very good question. So let's move to next question. This question uh, I also put it in your IIT mega mock of the crash course, if you remember. So basically what we have to do, delta S equation is given. Okay, so we have to find, in this question we have to find what? We have to find what? Sm minus Sm naught. Sm minus Sm naught. Sm is your entropy at any concentration, and your Sm naught is entropy of molar entropy at standard conditions. So standard molar entropy is Sm naught, and entropy of 1 mole of ideal gas is just normal entropy, molar entropy, not at standard condition, that is Sm. So Sm minus Sm naught is your delta S, right? And delta S equation is this. So this will be N Cp ln T2 T1 plus R ln P1. So P1 is Sm naught. So this will be P naught by P. Okay. So they are said that the temperature is constant. So this whole thing is constant. So this will be basically 0, nothing else. P naught is 1 bar as per the question, standard pressure, right? And N is 1 mole, right? So basically this is Sm minus Sm naught is equals to R ln 1 by P, or you can write it as minus R ln P, right? So this is why this is M, slope will be negative, minus M, R minus R, and this is ln P. This is what? Your X. So as your ln P will increase, as your ln value will increase in positive, so if ln P, let's suppose this is positive, pressure is more than 1, so pressure is more than 1. If pressure is more than 1, ln P will be positive, ln P will be positive. So if ln P is positive and you are going on increasing ln P, so this will become more and more negative. So basically Sm minus Sm naught will become more and more negative and more negative. So see, you are increasing ln P in positive value, right? So Sm minus Sm naught is going on in negative value. Now if your P is less than 1, pressure is less than 1, so ln P will be less than 0, it will be negative. And if you are going to make it more negative, more and more negative, so this Sm minus Sm naught will become more and more positive, more positive, right? So you make ln P more and more negative, right? More and more negative, your Sm minus Sm naught is becoming more and more positive. So your answer is D. Okay. Chalo. Okay, so this is again a question of structure of atom. This is a very good question. So basically I'm not going to do the whole derivation, I'm going to just tell you the concept. It will be your homework, just do the derivation, you can do it. Okay, so I will just give you a hint. So basically there is a hypothetical 1 electron atom in which nucleus and electrons interact with a force F minus Kr. So what they are saying, this is nucleus, and if this is my electron, wait, this is my electron, and basically nucleus is attracting electron towards itself, Okay, okay, and this electron is revolving around it, because this is a question of Bohr's orbit, Bohr's radius, Bohr's model, right? So in Bohr's model, electron was revolving around the nucleus, right? So let's suppose electron is revolving around the nucleus. So if it is revolving around the nucleus, this is uniform circular motion, uniform circular motion, because this is revolving in circular orbits, right? So if this is revolving in circular orbit, this attractive force is F is equals to minus kr. K is constant, so there must be a pseudo force that is being applied outside to make this circular motion as uniform circular motion. To maintain this radius, there must be a centripetal force, a pseudo force that is being applied on the electron, right? So outside, so there must be a centripetal force. So this force is mass of electron v square by r, speed of electron by r. R is the radius of Bohr orbit, radius of Bohr orbit, simple, right? Right. So basically these two things are equivalent, minus kr, equal and opposite force is there, na? So minus kr is equals to, or basically magnitude will be equal, so we can equate the magnitudes. Why we need to equate the signs? So m e v e square r square, right? Not r square, r. So basically we need to find the velocity of electron in nth orbit, right? So from here we can say that r square kr square is equals to m e v e square, and we also know that angular momentum is equals to m e v e r is equals to n h cut. H cut is h by 2 pi. Okay, so from here we can say that r is n h cut by m e v e. So we can put r here. So put r here, put r value here. So k n h cut square, okay, not square, wait, n h cut by m e v e square m e v e square. Okay, so you can do the further derivation, or should I do? Let me do. Okay, no problem. So this will be k n square h cut square m square v square. Okay, so this will be m v square. So v square will go there. So from here you can write v square v4, because v square into v square will be v4, right? v4 will be k n square h cut square by m cube, right? So then from here v will be k n square h cut square m cube to the power 1 by 4, n square h cut square k m cube to the power 1 by 4. So see, this is the answer. So the purpose of this question was such type of derivative questions. This is derivative question, this was all derivation. So this can come. So the purpose of this question was to develop your thinking. So this question can come. So if such question can come, or if such question comes in nest, so don't be like shocked like what is happening, or just try to first make a relationship of what has been asked. Okay, then things can be happen. Okay, so this derivation was not very difficult, it was 4-5 step derivation, but the point is a lot of people won't be able to think like this, right? So make sure that you should be prepared. Okay, so now this is equilibrium constant. In this, basically we have to consider gaseous reaction where equilibrium constants are related by Kp is equals to Kc RT delta N. Okay, so for a reaction where delta N is -2, which of the following statements is correct? So we have to find the correct statement. So a plot of log Kp versus log Kp by Kc versus log Rt will be straight line with slope 2. So Kp, see, Kp is given as Kc Rt delta n. So Kp by Kc is equals to Rt delta n. So if we take log both sides, so log Kp by Kc is equals to delta n log Rt, right? Right? Uh, so basically we have to plot log Kp by Kc with respect to log Rt. So the slope will be this. This is y is equals to mx, na? So this is slope. So if this is slope, this is obviously delta n is minus 2. So slope is minus 2, not 2. Okay. So this is wrong. At temperature T is equals to 1 by R. Temperature T is equals to 1 by R. Numerical value of Kp and Kc are equal. So Kp and Kc, put value of T is equals to 1 by R. So Kp is equals to Kc R into 1 by R delta n. So this will be 1. So 1 to the power anything will be 1. So Kp will be equal to Kc. So correct option is your B. If you want to see other options also, we can see Kp will always be less than Kc regardless of the temperature. No, that is not right, because Kp by Kc is your Rt delta n, right? Kp by Kc is equals to 1 by Rt square then, right? Because delta n is minus. So if this is 1 by Rt square, so regardless of the temperature, so let's say if your temperature is less than 1, temperature can be less than 1 Kelvin. Temperature is less than 1 Kelvin. So this will be 0 point something something. So Rt square will be less than 1, much less than 1, whatever. Rt square will be much less than 1. So if this is less than 1, so 1 divided by something less than 1. So Kp by Kc will be greater than 1. So Kp will be greater than Kc in that case. Okay. Okay. So R I am taking at right now R I am taking as 8.314. Okay. So Kp will always be less than, no, see, Kp is greater than Kc. See. So I told you this is incorrect. So the units of Kp and Kc are identical for this reaction. No, because see, Kp is Rt delta n, right? Kp is Kc Rt delta n. So Kc has the units of mole per liter. Like for this reaction, Kc will be having mole per liter your into Rt delta n. Okay, and Kp will have values of atm because it is in pressure. So if this is in pressure, so basically mole per liter into Rt delta n, I mean, it does not make any sense if you you know, you can utilize or analyze this. So basically this should be Rt should delta n should be 1. Why? Because see, pressure is what? N by V Rt, right? So this N by V is the concentration of gaseous molecules. This is the concentration, right? So if Rt is 1, then only it will be equivalent to pressure. Are you able to understand? First of all, and if nothing is given, the reaction is not given, nothing is given, so delta n is minus 2. So you can take the reaction as, let's suppose, A plus B plus C as D. So this is delta n will be 1 minus 3. Delta n will be 1 minus 3 minus 2. Something like that. You can take that, assume like that. So if you are assuming like that, Kc will be mole per liter divided by mole per liter ka cube. So Kc will be something like mole per liter minus 2. That will be Kc in this one, right? So Kp will be atm minus 2. So these are not equal values, no? These are not equal units. Units of Kp and Kc are not identical, right? So that won't be the thing, no? Okay. And your case Kp is equals to, basically Kp is equals to Kc RT delta N. So Kc mole per liter minus 2 RT delta N. So RT minus 2. So mole per liter minus 2 into RT minus 2. That does not make your ATM minus 2. Okay. See, this will be mole per liter minus 2 into RT minus 2. Okay. So this will be 1 by mole per liter square and 1 by RT square. So then it does not make any sense, I think. Okay. Chalo. So this is also not correct. So the only correct option is your B. Okay. Okay, so let's move on to the next question. So basically we know that Kp, Kc can't have same values and all that thing, right? Same units, and we have calculated temperature and all. This question was good. So such questions can come. So from equilibrium, so this is also wrong again. So let's move to next question. Okay, so basically this year S block and P block has been added to your NEST syllabus. So maybe some questions from S and P block can be asked. So basically boiling points of hydrides of group 5 have been asked. So if you see group 5 hydrides, so it will start from NH3, then PH3, then your ASH3, then your SBH3. So obviously if you see the, basically they are asking about the boiling point, right? So boiling point, obviously this means that they were in liquid form and then they went to gaseous form, right? So in liquid form or in gaseous forms, basically here what will happen? So down the group if you will go, your intermolecular interactions decrease. Intermolecular interactions increase. Did I say decrease first? I'm sorry. I didn't mean decrease, they increase. Okay. Why? Because if you have studied the van der Waals interactions and all of that stuff, so these types of interactions are basically dependent on the molecular mass. Okay, so down the group molecular mass increases, so intermolecular interactions increases. Can there be any other reason? Let me think. Molecular mass is fine. Okay, so that is the reason. So because of that, intermolecular interactions increase, so down the group obviously boiling point should increase. But what happens is there is an anomaly here, and anomaly is never an anomaly, there is always a reason. NH3 will undergo hydrogen bonding. So because of strong hydrogen bonding, there will be we need more temperature, we need to give more energy to boil this, so this will just shift down 2 places. So your correct order will be this. So highest boiling point SBH3, then NH3, then ASH3, and lowest boiling point pH3. Okay. Okay, sure. Again another question from your S block, that was P block question, group 5. This is S block question. Basically group 2, your metal carbonates are given and we have to find the increasing order of thermal stability. So thermal stability, for thermal stability you need to know that group 2 metal MCO3, when you will heat it, what will happen? It will convert to MO plus CO2 gas. So thermally it will decompose. When you will heat it, it will decompose. So thermal stability tends to the quality of not decomposing of a metal carbonate. So what will happen here? As you go down the group, see, as you go down the group, here beryllium carbonate, then your magnesium carbonate, then your calcium carbonate, then your strontium carbonate, then your barium carbonate. So what happens is, down the group, obviously size of cation, size of this cation, beryllium, magnesium, calcium, they all increase, sorry, what am I saying? Size of cation increase. So if this size increases, it does not polarizes oxygen more. So what will be the bonding like? See, the bonding will be like something like this. So metal and carbonate, wait, COO minus minus double bond O 2 plus. So this will be bonding will be something like this, right? So metal is bonding with oxygen, not carbon. So what will happen if this metal has high polarizing power? High polarizing power. If you don't know Fajan's rule, please go and revise. High polarizing power. So if it has high polarizing power, it will form strong bond with oxygen. Strong bond with oxygen. And when we will heat it, what will happen? It will take oxygen and basically CO2 will remove. So because it has strong bonds with oxygen, it will take one oxygen and CO2 will remove, and basically MO will be left and CO2 will remove. But if it has low polarizing power, it means it has low polarizing power, it won't polarize the electron density of oxygen much. So low polarizing power, and low polarizing power means higher size increases, that means down the group polarizing power decreases. So this means that weak oxygen and metal bond. So down the group oxygen metal bond is weak, so when you heat it, so all of the CO2 will go and CO3 2 minus will go, and basically metal will not be bonded with oxygen anymore. So basically down the group thermal stability increases, it won't decompose like this. Okay, so it will be like carbonate only. So beryllium carbonate, magnesium carbonate, calcium carbonate, strontium carbonate, and then barium carbonate finally. So your answer is A. Okay. Okay. So this is again a question from your IIT Mega Mock. This question is, I couldn't find any good question here. I'm really sorry for that. But the motive of this question was to tell you that ligand field strength, and the question related to ligand field strength like absorption frequency, wavelength, and color as well. So these are important. So please revise that. Okay. So here, uh, because of the time constraints, I couldn't find any better question than this. So I just reuse the IIT Mega Mock question. So basically, we have to find the frequency of absorption, order of frequency of absorption. So frequency of absorption will be directly proportional to uh, del naught O, like crystal field splitting. Crystal field splitting. Okay, so this will be directly proportional to first what? Oxidation state of the metal. Oxidation state of metal. Second, size of metal. Higher the size, higher the crystal field splitting. Third, if everything is fine, size means period. Like so 3D series have lower size than 4D series, and that. So period, you can write it here. Not across the same period, I am asking. Across the same period, size does not fluctuate that much. So across the group or down the group, it fluctuates that much. So down the group you can write down the group. Okay, and third and final one is your, if all of these are same, oxidation state is same and metal belongs to the same period, you will see the ligand field strength. And obviously in this question the metal is same, oxidation state is same, so we'll see the ligand field strength. So ligand field strength is highest for NO2, then NH3, then H2O. Okay, NO2 minus, sorry, Okay, so if ligand field strength is high for this, so lambda naught will have this order only. So if lambda naught has this order, then frequency of absorption will have this order. Then ammonia, D. It should be D, na then. If ammonia, let me recheck. Maybe I'm wrong. Let me recheck, please. Okay, yeah. So I was right. The answer will be D. I mistakenly corrected it A, but it will be D. So now this question is from ionic equilibrium, basically from acid and base titration. So again, this question is not a very good question as per the NEST standards. I am very sure about that, obviously. So such easy questions won't be asked. They might be asked maybe if your luck is right. So they might be asked, but generally such easy questions are not asked in NEST. The purpose of this question, asking this question, is to tell you that you need to do titration. Do titrations, acid-base titrations, indicators, methyl orange, phenolphthalein, like equivalence point, end point, half of equivalence point, whatever. So this part of ionic equilibrium generally we leave. So don't do that. Okay, please make sure to do this as well. So basically here acid-base titration is happening. So 0.1 molar HCl solution is added to NaOH solution of unknown strength. So anything of unknown strength is in the conical flask, and the known strength solution will be added from burette. So in the conical flask, if NaOH was there, so conical flask was basic in the starting. So then HCl will be added, then pH will be in the starting, pH will be greater than 7, like obviously basic. So then pH will go on decreasing as HCl will be added, because HCl will then neutralize the OH minus, right? So pH will go on decreasing and something like this will happen, and then it will go to constant. So this is a strong acid and strong base titration curve. Okay, if this would have been a weak acid weak base titration curve, it would have been it would not be dropped like suddenly. It would have been very slow, something like that, and this. Okay, something like that. So basically you have to, basically this question is a reminder that you have to revise titrations as well. Okay, sure. So first order reaction graph is given, log A versus T is given. Okay, so we have to find the value of x is slope. So again here first order equation will be log A T by A naught is equals to minus K T, right? So minus KT by 2.303. Why? Because ln form of the equation is ln AT by A naught is equals to minus KT. So you convert this into log. So log AT by A naught, because ln is 2.303 log. So 2.303 will go down in the denominator, 2.303. That is the thing. So if this is the thing, so we have to find log A T is equals to log AT minus log A naught is equals to minus KT. So this will be log A naught minus KT by 2.303. Okay, so this is Y, this is C, this is Mx, M is your slope, right? So M is your slope, so M is your K to the power, slope is X, no? So slope is X, so M is your minus K by 2.303, that is X. Okay, so minus K by 2.303. If they would have written slope is equals to minus X, then I would have written K by 2.303, but here it would be minus K by 2.303. Okay, okay. So this is the last question. So this is from general periodic table, or basically I took this question because this is the question which contains periodic table properties as well as P block question, P block properties. So again, so please revise S block, P block, in general all the properties of the periodic table. Okay, so basically we have to find the incorrect statement here. So here the elements that have similar properties will have same group on the periodic table, that is the thing obviously. So any element in basically 14th group will have properties like carbon. So silicon has properties like carbon, right? silicon, carbon, silicon, tin, germanium. So basically they have same properties, right? Any element in the 15th group will have same properties as that of nitrogen, phosphorus, arsenic, because they have the same valence electrons. And chemical properties are generally, and basically a lot of physical properties also are generally based on the number of electrons, valence electrons. So basically valence electrons are same, valence electrons same. So because of this, same valence electrons properties are similar, not same but similar. Okay, among elements of group 17th, fluorine is the most reactive, that is fine. Group 17th is halogen group, F2Cl2 Br2 I2. Fluorine is most reactive. This is wrong because of low oxidation power. No, oxidizing power. No. So if this is oxidizing someone, it means this is taking electrons from someone. So tendency of fluorine to take electrons is very high because this is highest electronegativity is that of fluorine. So basically tendency to take electron is very high. So it is a good, or it has high oxidizing power. Okay, high oxidizing power means tendency to take electrons is high. Secondly, this fluorine bond is very weak. Why? Because fluorine has very high charge density. It is a very small atom with very high number of electrons. So high charge densities, so they will repel each other. So when they will repel each other, they will go away. So this bond become weak. So because of weak bond, so weak bond means low dissociation energy. We need to give less energy to dissociate the bond because the bond is weak. So basically both of the things, high dissociation energy and low oxidizing power, both of them are incorrect. So generally on moving down the group, ionization energy decreases. Yes, because moving down the group, if you are going down the group, size increases. So size increases, that means the outermost electron goes far and far from the nucleus. So it is very easier to remove the outermost electron. So ionization energy your increases. And organozone is the heaviest element in the periodic table. So that is also right because organozone is the last element. So till now it is the heaviest element. So obviously the incorrect statement is B. Yeah. Okay, so basically again these are the 50 most important questions. Again I will say that these questions does not mean that only these questions will come. So these questions means that basically these concepts can come, and S block, P block and the gaseous state, the chapters which have been added, please do those chapters, and please don't miss any topics or please don't think that this topic is not very important or this topic is not been asked from the previous year, so it won't be asked this time or whatever. So if you want to score full on full in chemistry in your nest, do 100% of your syllabus. I would say do 110% of your syllabus. Maybe they are angry this time and they will ask something out of the syllabus, I don't know, maybe. So do 110% of the syllabus. Be extra prepared, always be extra prepared. Okay, so bus, this was your 50 most important questions for your nest. I've already given you 50 most important for your IIT. So all the best to all of you. Just prepare well, just be positive, just do your hard work, and leave everything to your God if you believe in him, or leave everything to life, whatever, right? So just keep working hard. Result is not in your hand, but your hard work, your actions are. So just don't be demotivated, just be positive, be motivated, do your best, give your exam, and let's see what will happen. Okay, don't worry. Okay, bye bye.